Hello guys, today we're going to have continuity of functions. Can you trace the broken lines without lifting your pen or without passing through the same broken lines more than once? Continuity of function is like tracing the broken lines without lifting your pen and without passing through each portion of the line more than once. Now, let's take a look at the three graphs presented on the screen. Which do you think demonstrate or exhibits continuity of functions? In these three graphs, only letter A exhibits continuity of function. Take note that we can trace the graph in A without lifting our pen, passing each portion once. While option B, if we trace this graph, we need to lift our pen in order to trace the other parts of the graph. The same with option C, wherein we need to lift also our pen in order to trace the other portion of the graph. Hence, only the graph illustrated in A shows continuity of functions. Now let's describe continuity of functions formally. A function is said to be continuous at the number a if the following conditions are satisfied. First, f of a exists. Second, the limit of f of x as x approaches a exists. And the limit of f of x as x approaches a is equal to f of a. If any one or more of the given conditions fail, the function is said to be discontinuous at a number.
Let's work on example number 1. Determine whether f of x equals x squared minus 2x minus 3 is continuous at x equals 1.
We now show that the function satisfies all three conditions. So we show that f of 1 exists by evaluating the given function at x equal to 1.
So we will have 1 squared minus 2 times 1 minus 3.
Simplifying that, we will have negative 4. Therefore, f of 1 exists. Now let's show whether the given function satisfies the second condition, wherein the limit of f of x as x approaches to a exists. We show that the limit of x squared minus 2x minus 3 as x approaches to 1 from the left is equal to the limit of x squared minus 2x minus 3 as x approaches to 1 from the right. We evaluate the given function at x equals 1, so we will have 1 squared minus 2 times 1 minus 3. We also evaluate the given function at x equals 1, so we can see that they are both equal to negative 4.
Hence, we can say
That the limit of x squared minus 2x minus 3 as x approaches 1 is equal to negative 4. Hence, the limit x squared minus 2x minus 3 as x approaches to 1 exists. We can see that the given function satisfies the second condition. Now, what about the third condition? We are asked to show that the limit of x squared minus 2x minus 3 as x approaches to 1 is equal to f of 1. Now we can see that this is equal to negative 4 and f of 1 is also equal to negative 4. Then we can conclude that the function satisfies the third condition. So with this, we can confidently say that f of x is continuous at x equals 1. We used graphical method to confirm our conclusion or our answer that the function is continuous at x equals 1. Okay, so using GeoGebra or Desmos, we can have this graph and we can plot the point at which we have x equals 1. So here we have x equals 1. Now, if we will trace the function, we can see that we can pass through this point without
lifting our pen.
Hence, we can say that f of x is continuous at this given number x equals 1. x equals 0.
X equals 0. Evaluating the function at x equals 0, we will have 2 times 0 squared plus 11 times 0 plus 5 all over 0 plus 5. Simplifying, we will have 5 over 5, which is equal to 1. Thus, f of 0 exists.